Okay, let it. This is using Tcell inverter auto layout, semi auto layout. Close this file, new, click on it, then browse for generic.tdb file. Click browse, search for Tanner EDA folder, Tanner EDA, Tanner tools,Ledit and LVS, tech folder, generic 025 micrometer, generic.tdb file. Open, then click OK. Now go to setup, design, grid, select grid, change the major display grid, make it as 0.25 microns, minor display grid as 0.125, mouse cursor type smooth, click OK. Cell, copy, browse for Tcell, Tanner tools, Tanner EDA, Tanner tools, Tanner EDA folder, Tanner tools. You are going to have Tcell folder. Open, click open, select Tcell, click OK. Select TC NMOS for NMOS, click OK. Select ignore different technologies, then click OK. Go to cell, copy, browse Tcell again, click OK. Select TCP MOS, click OK. Then click OK by selecting ignore different technologies. Instance, select TCP MOS, click OK. OK. Place it. Next, cell, instance, select NMOS, then click OK. OK, and place NMOS below PMOS. Next, go to cell, copy, browse, select NMOS substrate, click OK. Browse again, select PMOS substrate, click OK. OK. Cell, copy, NMOS, OK. Click OK. Next, go to cell, instance, select PMOS sub, click OK. Place it next to NMOS. Okay. Cell instance, place PMOS NMOS substrate next to PMOS. Go to cell, flatten, click yes. Now next, select PMOS substrate and place it next to NMOS, as PMOS substrate is ground and NMOS substrate is considered as VDD, so place it next to VDD. So place it next to NMOS. So if you select layer by layer, you can see below here the dimensions. On the left hand side below, you are going to see the dimensions for metal layer, active layer, poly, as well as active contact on the left hand side below. Next, select the metal layer, place the cursor on the edge. You can stretch it and connect the metal VDD to PMOS substrate. Now by selecting N-well, extend it and cover it VDD. Run DRC to check any errors are there. Metal wall density error can be neglected or ignored. Similarly, select metal one of ground and connect it to VDD. Connect it to NMOS. So now draw the connections. Select poly and extend the poly and connect PMOS poly to NMOS poly. Select the whole NMOS and align it properly with PMOS poly. After placing it, next select the drain, drain of NMOS and connect it with drain of PMOS. So this completes inverter design. So DRC for checking any errors are there. Metal one density can be ignored. Error can be ignored. So next, naming it. Select port A, switching to port names. Name it by clicking on VDD metal layer. Edit object, select metal layer, metal 1 and name it VDD. If you want to increase the size, increase it to 0.42, then click OK. Similarly, poly, change it to change its size and place it. Similarly, for output, select metal 1 layer, click OK. Y, name it as Y, then change the size of it, click OK. Similarly, for ground, click on metal 1 layer, change it to metal 1 layer, name it port name as ground and change the size of it, click OK. And this completes the design. Now next, go for setup extract. Save the design before. So you have to save all the designs in a single folder. Like for all inverters, it has been saved inverter schematic layout in NT4 folder. Similarly, you have to save all in the same folder. Save it, run DRC. Next is setup extract. After saving, click extract standard rule set, then edit selected commands, then browse for the extraction file. Go in search of Tanner EDA folder. Next, Tanner tools,Ledit and LVS, tech folder. Under this, generic, Select this, then click OK. Change the spice file name. Save it. And delete this line, then click OK. Now run extract. Now the spice file is generated in the particular location. Open the location. Go to E drive, EDA design, EDA, under EDA NT4 folder, search for NT4 folder, design folder, the name of the design which you have given. So here open the spice file of it. Now insert the cursor below the commands. Now start giving one by one commands through insert command. First is under analysis transient, 10 nanoseconds and 100 nanoseconds. Next is DC transfer sweep linear type parameter source name V1, start 0, stop at 5 volts, increment 0.1, accept, insert command. Next, files, search for library file, browse for it, search for EDA folders, Tanner EDA folder, Tanner EDA, Tanner tools, libraries, models, select generic 025 .lib, type TT here, insert command. Next, voltage source, bit V1 A, positive always input, negative ground, waveform give bit format, bit values, then insert command. Constant V2 VDD ground, DC 5 volts, insert command. Next, output, select output, DC results, node name you have to give output only here, add to the graph, add to the plot, insert command. Next, transient analysis, both input as well as output you have to give one after the other, add it to the graph, then insert command, close, type .op, save it. Now run for simulation. Wait for simulation results. So here you got the result. First one is DC transfer characteristics, and the second one is output in green color, and the first one is an input.